Okay, and finally we reach the final exam review, chapter 11. Okay, this one says, problem number 1, a standard six-sided die is thrown. If each face is equally likely to turn up, find the probabilities. And so remember, our sample space here is 1, 2, 3, 4, 5, 6. And on all of these, it's much easier if you draw out the sample space. All right? So it says, a six-sided die is thrown. If each face is equally likely to turn up, find the probabilities of 3. So there's only one way to get 3 out of a total of 6 ways of getting anything. So that would be one way of getting what you want out of 6 things in the sample space, and so it would be 1/6. The probability of getting an even number, well, the even numbers are 2, 4, and 6. So there's 3 ways of doing that out of a total of 6, and if I reduce that, it would be 1/2. And then probability that the number is greater than 4, so the 2 numbers greater than 4 would be 5 and 6. So there's 2 ways of doing that over a total of 6, which would give me, if I reduce to lowest terms, 1/3. All right? So here we have, problem 2 says you have a key ring with 5 keys on it. Enter the exact answers. One of the keys is a car key. What is the probability of picking that one? So here you only have one key that is a car key, and there are 5 keys altogether. So the probability of picking the car key would be 1 out of 5. Then it says 3 of the keys are for your apartment. What is the probability of selecting an apartment key? So here they tell you that you have 3 ways of getting what you want, the apartment key, out of a total of 5 keys. So that would be 3/5. And then C, what is the probability of selecting either the car key or an apartment key? Okay, so here I have a car key, apartment, 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 and then I have some other key that they haven't mentioned what it is. So 1, 2, 3, 4, 5 keys. So if you want to select either a car key or an apartment key, that would be 4 ways of getting what you want out of a total of 5. Or you could say, remember, or means add. And since there's no overlap here, there's no intersection of these two, I could just say it's 1/5 plus 3/5 would also give you 4/5. And then what is the probability of selecting neither the car key nor an apartment key? So there's only one way to do that, 1 out of 5. Or since it's the not of this one, I could say 1 minus 4/5, which would also give me 1/5. So any way you want to do it is fine. Okay? Problem 3 says, a loaded die, one of which outcomes are more equally likely, is tossed 1,000 times with the following results. Oh, and I should have, so this is 125, this is 75. I will fix this before I give it out to y'all. So what's the probability of getting a 2? All right, so that would be 75 over 1,000, because we tossed it 1,000 times and 75 of them, and here we're looking at the experimental probability. All right, so that would be 75 out of 1,000. The probability of getting a 5 would be 160 over 1,000. Probability of getting a 1 or a 5 would be 125 plus 160 over 1,000. And so that would be 285 over 1,000. And the probability of getting an even number, well, the even numbers would be the 2, the 4, and the 6. The 2, the 4, and the 6. So that would be 75 plus 160 plus 40, not 160. The 4 is 270, sorry, over 1,000. And so that would give me, let's see, I'll just do it on the calculator so I don't make an error. 75 plus 270 plus 40 equals 385 over 1,000. Now if I reduce this, so 385, it won't let me it won't let me do 1,000. All right, so let's see, both of these are divisible by 5. So this would be 77 out of 200. Okay, 285 divided by 5 gives me 57 out of 200. And then this one I can cancel a 10. Then they're both divisible by 4, so that would be 4 over 25. And then 75 is divisible, they're both divisible by 25. So this would be 3 out of 40 if I reduce everything. All right, so that's problem number 3. So now let's go to another sheet of paper. Chapter 11, problem number 4. Draw a probability tree diagram for the experiment. Drawing a marble from one box containing 1 yellow and 1 green marble, and then drawing a marble from another box containing 3 yellows and 2 red marbles. All right, so first we have 2 boxes. One of them has a yellow and a green. The second one has 3 yellows and 2 reds. All right, and so I'll make this one go sideways. So this is the first, and this would be the second. Now notice that what happens on the first one will not affect what happens on the second one. And so they are independent of each other. So here I can get either a yellow or a green, and I've got a 1 out of 2 chance of getting a yellow and a 1 out of 2 chance of getting a yellow. And here I can get on my second pick, this is out of the second box, so I can either get a yellow or a red. There's 3 out of 5 chance of getting a yellow because there are 3 marbles that are yellow out of 5 marbles altogether. The probability of getting a red would be 2 out of 5. And then the probability here, if I pick a green on the first one, I'm still picking from the second box, so I can get either a yellow or a red. And again, this would be 3 out of 5 to get a yellow and 2 out of 5 to get a red. And then finally, this would be yellow, yellow, and my probability, I just multiply down the chart. So 1/2 times 2/5 would be, times 3/5 would be 3/10. This would be yellow, red, and that would be equal to 1/2 times 2/5 would be 2/10, and I'm not going to reduce that yet. This would be green, yellow, and that would be 1/2 times 3/5 would be 3/10 again. And then this would be green, red, and that would be 1/2 times 2/5, which would be 2/10. Now, the reason I didn't reduce, and I will come back and reduce, but in a second, I wanted to first show you, notice that these add up to 1. So this branch of the tree adds up to 1. This branch of the tree, 3/5 plus 2/5, adds up to 1. This branch of the tree, 3/5 plus 2/5, adds up to 1. And then if I add all of these up, 3/10 plus 2/10 is 5/10, plus 3 more tenths is 8 tenths, plus 2 more tenths gives me 10 tenths. So this line also adds up to 1. Now you should reduce these. This is 1/5 and this is 1/5. All right? So that's problem number 4. Problem number 5 says, Apricot Apparel sells shirts in 5 different styles, 6 different sizes, and 10 different colors. How many different kinds of shirts do they sell? So there's 5 ways to pick a style. Then there's 6 ways to pick a size. And then there's 10 ways to pick a color. So 5 times 6 is 30, times 10 is 300. So there are 300 different kinds of shirts that they sell. Okay? Problem number 6 says, permutations of 7 choose 5. Now on here, I will ask for you to show me what you're doing. I do want the answer, but I also want to see what you're doing. So remember, the formula for permutations is n factorial over n minus r factorial. For combinations of n choose r, it's n factorial over r factorial times n minus r factorial. So remember, these two add up to give you n. So on this one, this would be 7 factorial over 7 minus 5 factorial. So this would be 7 times 6 times 5 times 4 times 3 times 2 times 1 over, and this would be 2 factorial, so 2 times 1. So these would cancel. And you can do the calculations on your calculator and not have to do all that multiplication. So I'm just going to go 7 PRN5, So this gives me 52 at 2520. All right, so that is that. Or I can do 7 times 6 times 5 times 4 times 3 equals 2520. All right? And I'm sorry, this should be a C here. So this one says combinations of 12 choose 4. So this was part A. Part B, combinations of 12 choose 4. And so this is going to be 12 factorial over 4 factorial times 12 minus 4 factorial. So this would be 8 factorial. And so this would be 12 times 11 times 10 times 9 times 8, 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1, and then 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So all of these cancel with all of these. 4 times 3 would cancel with 12, and then the 2 would cancel with the 10 to give me a 5. So basically I have 11 times 5 times 9 equals 495, right? Or you can do it with your calculator, and you have 12 and then CNR of 4, and you get 495. But you do have to show me that this is what you're doing, all right? And then finally, part C, 9 factorial over 6 factorial is equal to 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 6 times 5 times 4 times 3 times 2 times 1. these cancel with these, and I have 9 times 8 times 7 equals 504. And then you can check yourself using the factorial button. Mine is right here. So it would be 9 factorial divided by 6 factorial equals 504. All right? Okay. Problem number 7 says, Coffee has forgotten a 4-digit combination required to unlock his bike. He could still remember that the digits were 1, 2, 3, and 4, but couldn't remember their order. What is the greatest number of combinations that Coffee would have to try in order to unlock the lock? Now, really here on a combination lock, and we've talked about this before, combinations, it's not really a good word for it because it's really a permutation is what we're looking for. So notice that there are 4 ways for him to pick the number, the first number. Then there's 3 ways to pick the second number, 2 ways to pick the third number, and then only 1 way to pick the fourth number. And so that would be 24 different ways that he could pick those 4 numbers. Problem number 8 is basically the same question. It says, in how many ways can 5 chairs be arranged in a line? So there would be 5 ways to pick the first number, 4 ways to pick the second, chair, 3 ways to pick the third chair, 2 ways to pick the fourth chair, and 1 way to pick the last chair. And so that would be 5 times 4 times 3 times 2 times 1, and that is 120 if you multiply it out. All right, so problem number 9 says, a card is drawn at random from a standard 52 card deck. Find the odds in favor of drawing an ace of spades. All right, so there are 52 cards. Now remember, when we're doing odds for, it's the number of ways of getting what we want or winning compared to the number of ways that we would lose, right? And so how many ace of spades are there? Well, there's only 1. And how many cards are there that are not the ace of spades? 51. And remember, this has to add up to give us our entire sample space, all right? Part B says, find the odds against drawing a king or a 4. Now, there are 4 4s and 4 kings. So there are 8 ways of getting what we want. So now, but here I'm doing odds against. So my 8 is going to go over here. And then remember, if I take 8 of those cards out of the 52 card deck, I would get 44 cards. And remember, these have to add up to give me 52. All right. And then finally, we're going to do one that is without replacement. And I'll just do it on the sheet here. It says a jar contains 5 red and 7 blue marbles. Okay, 1 marble is drawn and not replaced. All right, so we can either, so this is the first draw, and there are 12 marbles. All right, now if I pick a red, so this is second draw, if I picked a red on the first one. So here I would have 4 red and 7 blue, and I'd have 11 marbles. And this is on the second draw. If I pick a blue marble, then if I picked a blue marble from here, I would still have 5 reds, but I would only have 6 blues. And again, I would have 11 marbles. Okay? So problem number 10 says, part A, what is the probability of getting a blue and then a blue? All right, so picking a blue on the first draw would be 7 out of 12 times, now on the second draw, notice I've already picked a blue on the first draw, so now I'm going to have 6 out of 11, because in this marble where I picked a blue on the first draw, I have 6 blue marbles out of 11 marbles altogether. All right, and so if I want to reduce this, this would be 2, so I'd have 7 out of 22. Part B says, what's the probability of getting a blue given that you got a red in the first draw? So now I'm not worried about what happened in the first draw. I already know that I got a red in the first draw. So now I'm coming to this box. And so now the probability of getting a blue marble would be 7 out of 11. All right? And then part C says, what are the odds of picking a blue on, and this would be odds 4. I'll fix that. The odds for picking a blue marble on the first pick. And so that would be 7 ways of picking a blue marble compared to 5 ways of not getting a blue marble. And again, it has to add up to the entire sample space. So that is chapter 11, and we are done.